Okay, so the next part we're going to do is we're going to solve a linear equation by graphing. So we're going to take a look at this problem and see how to do that. So this is kind of a new method, nothing that you've probably seen before, but it's an interesting way to do it because what we're going to do is when we look at solving by graphing, we're going to look at where does it cross the x-axis, and that would be the solution to the equation, or the root. That's another word. It's the root to the equation, or it's the zero. So the zero is located when y is equal to 0. So the root, the solution, and the 0 all mean the same thing. Okay, so we're going to take a look at how to do that. So one way to do it is I could move everything over and solve for x. So if I move this to the right, I'm going to subtract 9 from both sides. So I get 6 equals 3x. And 6 equals 3x, divide both sides by 3, x equals 2. So x is going to equal 2. So it's definitely going to be d. Just by solving it. So that's one way to do it. We're going to see another way now, which is by graphing. So 9x plus 6 equals 12x. So this is just a different method. It depends on whether you like to look at it in as a equation or how you want to kind of deal with it. So what I'm going to do is I'm going to move everything to one side. So it doesn't really matter which way that I move everything, but I'm going to move everything to one side so that we can see how to solve this particular equation. And the only thing I really care about is where it crosses the x-axis. So what I'm going to do is I'm going to move this over. So I think I did it the other way in class, but if I move that over to that side, I get negative 3x plus 6 equals 0. And then what I'm going to do is I'm going to, instead of setting it equal to 0, I'm going to set it equal to y. So y equals negative 3x plus 6. So what does that tell me? That tells me that I have a y-intercept. 1, 2, 3, 4, 5, 6. I have a y-intercept all the way up here. This negative 3 is the slope, so it tells me to go down 3. 1, 2, 3. And over 1, so I'm going to go down there. Go down 3, 1, 2, 3, over 1, so it's going to cross right there. So I can see it right there that my equation is going to look something like that. Okay, so that's what my equation is going to look like. And I can go ahead and I can graph that one, and I can see where it crosses. So of course in this particular case it crosses at 2. And so x equals 2 would be the answer. So out of all of these graphs, the only one that crosses at 2 is D. So I can check my answer. But I want to show you something interesting because notice that I could have done something a little bit different. So there's my original equation. We're going to rewrite that out. So 9x plus 6 equals 12x. So I'm going to move this to the other side. So I get 6 equals 3x. And of course, you can see we can just solve it from there. But I'm going to keep going. I'm going to make it equal to 0. So I have 0 equals 3x minus 6. And so I'm going to replace that with y. Notice that my equations are different. So my first equation was y equals negative 3x plus 6. And when I did it differently, I got that answer. But that's okay. So I have a 1, 2, 3, 4, 5, 6. And I have a slope of 3, which is really 3 over 1. So that means we go 1, 2, 3 over 1. Go up 3, 1, 2, 3 over 1. And we still go through 2. It's a different equation, but it still will go through the same 0. So, or the same solution, or the same root. So all those things are equal regardless of which way that I do this. So just kind of keep that in mind. So really the important thing is that even if you solve it differently, the only thing that's important is where does it go through on the x-axis, and that will make sense for this type of problem. Okay, so the solution is 2. Okay, so it doesn't matter where it goes through, but the solution is 2. Okay. So estimate solutions by graphing. So we can do some estimations here, and if it's already graphed for us, that's really nice. So in this case, we look at this and it says, okay, find the zero of the function, interpret its meaning. So find the zero. So the zero, of course, is where it crosses the x-axis. So where it crosses the x-axis. And of course, it crosses right here. Look at around 9.5, somewhere around 9.5. So that means in 9.5 minutes, we have no more steps remaining. So that means that we get to the top of the tower in 9.5 seconds, or minutes, sorry, 9.5 minutes, not seconds. Okay, so that's what that means. Okay. Looking at this one, we can see that we have, for volunteering, this is how many hours we're supposed to volunteer, is 100, and this is how many months it takes. So in about 8.2, maybe 8.3 months, we have finished our volunteering. Okay, so 8.2, 8.3. Use the graph. So I'm going to say use the graph in tenths. So 8.2. We'll see what it says. Okay, so it was okay with that. So then I can solve it algebraically to verify the number. Here I have this. M represents the number of months. So V equals 100 minus 12M. Just want you to be able to see how to do this type of problem. So V equals 100 minus 12M. And of course, we want to figure out how many months does it get to zero volunteering. So this number would be 0. So 0 equals 100 minus 12M. Do I need to graph it? No, I can actually go through and solve it. So I'm going to add 12M to both sides. Now, the reason why I'm adding 12M again is because I don't want to deal with negative numbers. And if I move that over, that's going to be negative, and this will be negative. I'll still get a positive number, but it's just harder to deal with those. Sometimes you have to, but if you can avoid it, you always can. So it's 100 over 12. So we're going to go over to our calculator. We're going to type in 100 divided by 12 is 8.333. So we were close, not exact, but we were close. So that's what we do when we're looking at those types of problems. And I think this is the check. So you can go through and you can do the check. You don't have to do it by graphing, but because you can always solve it and figure out what the answer is too. So you can do it either way.